Alright, so I want you to answer your review questions. What does it mean when two figures are similar? Because we are going to look at perimeters and areas of similar figures today. So it's important to review what is a similar figure. Ian. So there's two parts to similar figures. How do we know if two figures are similar? What angles? So corresponding, and these would be interior angles. Corresponding angles are congruent, and there you go. And corresponding sides are proportional. So question number 2, are the corresponding angles of similar figures always congruent? Yes, because that's part of the definition, so it always has to happen. Number 3, are the corresponding sides of similar figures always proportional?
Yes.
Yes. So there's your two pieces. Circle the pairs of similar figures. So it's not enough to look at the angles and the sides and determine that they're similar. Look at number 4. Doesn't this side correspond to this side? And this side corresponds to that side. So you've got 2 is to 3 as 2 is to 3. Do you have the ability to determine if these angles here are congruent? They really should have put angle congruencies in there, because you're making an assumption. But we're going to go ahead and circle this one. I really would like to see this in here, and this in here, and this in here, and that in there. Yes?
Because of like all the stuff that we've learned, now it's like wouldn't that be a 45, 45, 90?
Yes.
Side lengths are the same?
Very good. I was also going to point out, well, remember our similarity theorems? How can we prove triangles are similar? By what theorems?
By saying
SAS, SSS, and ASS actually is one of them, right? So on here, we do have the ability, as Brody said, since these legs are both the same, this has to be a 45, 45, 90 triangle, and so does this. That's very true. So by did I say ASS? So by AA, those triangles you could prove are congruent. Also, don't I know 2 sides out of the 3 on a right triangle? Can you use Pythagoras' theorem to find the third side?
Yeah.
And they should also be proportional with a 2 to 3 ratio. And so we could have done that and proved it by SSS. So, what about the second figure? Well, this is a square and this is not a square, so we don't even have to try there, right? What about these? So all of these are equal. All of these are equal, so it's all going to be 6s to 8s. But what about the interior angles? Is it enough to do, because this is not a triangle, so we can't do side, 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 side. Is it enough just that the sides are proportional? Could I push in this side in here and still have all sides the same length, and not push in the side over here and still have all sides the same length? In other words, can I take this vertex and push it in here? It could be slightly pushed in, couldn't it? Whereas this one is not. I have no way of telling, right? So I'm not going to say that those are similar figures. So be really, really careful. Now your book may have said that those are similar figures, but they haven't proven it to me. I haven't looked at the answers. So your vocabulary for today. We already looked at the apothem and the center. We're going to concentrate, whoops, it'd be handy if I had a marker there. Concentrate on the radius of a regular polygon. It's the distance from the center to the vertex. So some of you are already starting to figure that out based upon the last lesson. The difference between a radius and an apothem is that the radius goes from the center of that polygon to the vertex, whereas the apothem goes where? Center to what? How to the side? Perpendicular to the side. And then the main idea is that the radii of the regular polygon divides the polygon into congruent triangles. And you can see that down here on this figure right here. Wouldn't you agree that all of these triangles here, and we talked about that in the last lesson as well, are all congruent triangles? Assuming that all sides are equal. So, cross out the segment that is not a radius of the regular pentagon ABCDE. The minute that they said that it was a regular pentagon, we know that all interior corresponding angle, well, all interior angles are equal and all sides are equal. So we can make the assumption that those triangles inside there are equal. So which of the segments drawn is not a radius? Though F is a point. OF. So from here to here, what's that? That's the apothem. So the apothem's not the radius, but all the other ones are. OA, D, B, E, and C, right? So all the rest are radius. Number 6, the radii of a regular polygon are or are not congruent? They are. The triangles formed by the radii and sides of the regular pentagon are or are not congruent? Well, that's based upon what we read above. True. All right, so next. So we get a theorem. 10-7 perimeters and areas of similar figures. It says if the scale factor of two similar figures is a to b, so whatever that is, then two things occur. The ratio of their perimeters is a to b, and the ratio of their areas is a squared to b squared. Why do you think it went from a to b to a squared to b squared? What do you know about area versus perimeter? What are the units attached to area? They're squared units. What are the units attached to the perimeter? They're to the first power. So that's where that came from. And so if I know the ratio of side lengths, then that's the same ratio for the perimeter of the two figures and for the area of the two figures, as long as we take that scale factor and square the numerator and the denominator. And that's all that they're saying. So you need to know these. And so question 8 says the name for the ratio of the length of one side of a figure to the length of the corresponding side of a figure is the, I kind of just said it, is the what? What's this ratio here called? From similar figures, if we take the side length of one and put it over the side length of, it's the image over the pre-image. Say it again. There you go, scale factor.
Eric said it.
I know. Yep. Who did?
Eric.
Oh, Eric, I just can't hear. My ears are all plugged. Still. It's now going on week 4.
I mean, he was whispering still.
Oh. You weren't confident in your answer, is that what it is?
I just blurted out random things. So.
And plus it said scale factor here, right? So question 9, if the scale factor of two figures is 1 to 2, then the ratio of their perimeters is what? According to what they just said above, if the scale factor is 1 to 2, what's the ratio of their perimeters? Perimeters is to what power? First power, so it's still 1 to 2. If the scale factor of the two figures is 3 to x, then the ratio of their perimeters is what? 3 to x. So that doesn't change. It's the same. If the scale factor of the two figures is 3 to 5, then the ratio of their areas is what? And you can see that they're squaring them above there, right? So it would be 3 squared and 5 squared, which equals what? 9 to 25. If the scale factor of the two figures is 1 to x, then the ratio of their areas, which area has squared units, is 1 squared to x squared, which equals 1 over x squared. So here we go. Problem 1. Two similar polygons, so they gave you some very important information. They told you the polygons are similar. So that means their corresponding angles are congruent, their corresponding sides are proportional. Have corresponding sides in the ratio of 5 to 7. What is the ratio larger to smaller? So what'd they just do? Well, what's this ratio right here? Is that larger to smaller or smaller to larger? That one's smaller to larger. They just did a sneaky sneak on you. This is small to large. Let me see if I can rewrite that. So this is small to large, but they're asking you to go large to small. They just switched that on you. Of their perimeters, what is the ratio of larger to smaller of their area? So circle the similar polygons that have corresponding sides in the ratio of 5 to 7. So 5 to 7 implies we want to put smaller over larger. So if I put 5 over 10, what does that equal? 1/2. So that's not it. If I put 8 over 14, because we're doing small to large for the ratio itself, what does that reduce to? 4 to 7. So that's not it. So for the last one, I'm going to put 10 over 14. What does that reduce to? There's our 5 to 7. So these are the polygons we're going to be working with. And so number 14, in similar figures, the ratio of the areas or perimeters equals the ratio of the corresponding sides, which is the same, area or perimeter. They want to know what's the ratio that equals the ratio of the corresponding sides. Is it perimeter or area? Which one's squared? The area, so it has to be the perimeter. The perimeter is exactly equal to that ratio of sides. Number 15, in similar figures, the ratio of the areas or perimeters equals the ratio of the squares of the corresponding sides. So the ratio equals the squares. Is that area or perimeter? Okay. So they're hitting you over the head with something, aren't they? So complete the ratio of larger to smaller. So larger to smaller of the corresponding sides would be what to what? If it was 5 to 7, it's 7 to 5. So we're changing it up. So using similar figures is a little bit different than when we were doing dilations. Dilations, you had to have image over pre-image. Here, you can switch them so long as you maintain the consistency of your ratio. So if we're going to go large to small, make sure that your ratio is in the form of large to small. And so the ratio large to small of the perimeters would be what? Same or squared? Same, so 7 to 5. The ratio larger to small of the areas is now squared, so we have 7 squared and 5 squared, which is 49 to 25. Oh. So they weren't asking for the area or the perimeter in that last problem, they were just asking what the ratios were. So problem number 2, the scale factor of two similar parallelograms is 3/4. So that must be small to large. The area of the larger parallelogram is 96 inches squared. What is the area of the smaller parallelogram? So area, what do we do with that scale factor? So I'm gonna X out all this. It's a lot of work for what we're gonna do. So you're right, the area scale factor is squared. So if our regular scale factor is 3 to 4, then our area scale factor is going to equal the regular scale factor squared. So we're going to take the 3/4 and square that. And what do we get? 9 over 16. So that is the scale factor that we're going to use for our area. And so they said the area of the larger parallelogram is 96 squared inches. So do you want to go small to large or large to small? It doesn't matter. You have to make a choice. Okay, so we're going to go smallest to large. So that's how we're going to set up our proportion. So we're going to take our scale factor, 9 is to 16, and set it equal to, we know the area of the larger. So does that go in the numerator or the denominator of this fraction here? Because we went small to large, so we want to go in the denominator. So that 96 squared inches is here, and we're going to let this numerator be x. All you're doing is solving a proportion. Yes?
Why did you square it in the beginning? Why did you square it?
Because the ratio of areas of similar figures is always squared. And so we took the ratio to sides, and we had to square that ratio. Because remember, area has squared units, so you have to square that ratio, whereas perimeter has units to the first power. We don't have to square it if we were doing perimeter. So if they had said that perimeter was 96 inches, we would have left the 3/4 alone. All right, if you can reduce vertically when you have bigger numbers, I would. We can't, so we can't. You cannot reduce across an equal sign, so we're just going to cross multiply. So we get 16x is equal to, what's 9 times 96? What is it? 864 inches squared. And then we're going to divide by 16. Tell me what that is. 54 even? So 54, and that's going to be inches squared. Now, what does that represent? What does x represent? So therefore, the area of the smaller, and it's important that you recognize it's the smaller figure, or polygon you could put, is 54 squared inches. So without knowing anything about the smaller polygon, I don't know how many sides it has. I don't know what its side lengths are. All I know is that the ratio of the side lengths are 3 to 4. That doesn't mean that its side lengths are, any of the side lengths are 3. I just know it's 3 to 4. I can still find its area, which has its uses, which you'll see here in a moment. So number 3, the scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. How much should the larger piece cost? So it's a little bit different. They're going to walk you through it. So think, the ratio of the areas is the square of the scale factor, right? Aren't they talking about area? The smaller piece costs $2.50. Isn't that the whole window glass? Wouldn't that be area? What they're saying is the area of the smaller. That's the area of the smaller cost. They didn't give you the area, they gave you the cost of it. And they want to know what's the larger piece's cost. So we're going to look at the area. Don't know what the area is, but I do know the scale factor is 3 to 5. So they took and squared the 3 to 5. And what did they get? 9 to 25. So I could use a proportion to find the cost of the larger piece to the nearest hundredth. So if I take the 2.5 they've put up here, 250, they've put up here in the numerator, is that related to the smaller or the larger cost? So you might want to put off here to the side that they've done smaller is to larger. And again, you can do it in whatever order you want to, it doesn't matter, but they've chosen to go small to large. So then the 9 or the 25 goes here for small. The 9 or the 25? The 9. So you've got 9 here and 25 here. So what they're saying to you is if you've got cost that's based upon area, you can now use cost basis as one of your proportions or one of your ratios in your proportion. And so what we've done is we've taken the ratio of the area, which is the squared, to the ratio of the cost of the sides. And so we're just going to cross multiply and solve. So we end up with 9 times C is equal to 250 times the 25. So we get 9 times C is equal to, what's 250 times 25? 6250. And then we have the 9C and the 6250. What are you going to do to solve? Yep. So divide by 9. And then what is 6250 divided by 9? Say that again.
6.9.
Yep. So and the reason why I brought that out longer is because we're talking about money. Money is always rounded to how many places? 2 places. So if I round to this place here, look at what's next door. Does my 4 stay the same or bump up? Stays the same. So we've got $6.94 for the larger piece. And then last but not least, problem 4. So the area of 2 similar rectangles are 1875 feet squared and 135 feet squared. What is the ratio of their perimeters? What do you know about the ratio of the perimeters? Squared or unsquared? Unsquared. Well, we don't have the ratios of the sides at all. But we do know that if we had the ratio of the sides, all we have here are the areas. So look at what they've done here. They've taken the areas and they've done small to large or large to small. So they've done small is to large. That's what they chose. You could have reversed it. That's fine. Why did they set them equal to a squared over b squared? Because we have the area of the similar figures, right? And the area of the similar figures should be equal to the square of the scale factor of the side lengths, right? And we don't know what those side lengths are, but we know that it should be a squared and b squared. And so you're going to justify the step. Did they give that to you on the right? Oh, you get to make a choice on the right. So is it rationalizing the denominator, simplifying, taking the positive square root of each side, or writing a proportion? Which do you think it is? Our justification. You're looking down here. It's writing the proportion. So we're going to choose this one. Second step, what did they do? Yeah, they simplified. So we're going to take out one of the simplifies. Who wants to work with those big numbers? And notice that they did simplify, and they were okay to simplify because 135 and 1,875 are vertical to each other. They did not simplify across an equal sign. Okay? So then what do they do from here to here? This is something new that you haven't necessarily seen before in a proportion. What did they do from here to here? So they took the square root of the a squared and they got a. They took the square root of 9 and got 3. The square root of b squared and got b. And the square root of 125, which is 5 times 5 times 5, that simplified as 5 rad 5. And so we are going to take the square root of, take the positive. Why is it the positive? Right, there's side lengths, they can't be negative. So we took the positive square root of each side. And then what are they doing from here to here? They are rationalizing that denominator, right? And so take that one out. And then finally, what are they doing from here to here? Simple, that's all that's left, right? So we're going to simplify. Bless you. And so the ratio of the perimeters, we don't know what the perimeters are, but we know what the ratio is, equals the scale factor of 3 rad 5 to 25. So not only do we know the ratio of the perimeters, but we also know the scale factor of the sides. We don't necessarily know the side lengths, but we know what the scale factor is. All right, last thing, lesson check. You do that on your own. You're not even on the correct page. You totally zoned out and checked out today. Okay. So they're walking you through this, so read each question carefully and answer it, and they'll walk you through the solution. So let's chat about what comes next. So you have the area of one rectangle, and they do tell you it's a rectangle, so it's important to realize that you have a rectangle, is twice the area of another. So here's the area of the smaller rectangle. You don't know the dimensions, so it's base times height, which is x times y in this case. You could have used base times height, which is fine. But then the larger rectangle would have to be twice that, so it's 2 times x times y. And then they wanted larger to smaller, so the 2xy had to come first, and then the xy, because the 2xy is larger. Then if we want to know the ratio of the perimeters, the ratio of the perimeters is equal to what? What ratio? The scale factor. The ratio of the areas is equal to what? Not the scale factor, but the scale factor squared. So if I were to take and do, I don't know, we'll do a squared over b squared. And bearing in mind we're doing larger is to smaller. And then we have equals 2xy over xy, because that's larger is to smaller. Now notice what they're saying to you, find the square root of the ratio of the larger to smaller areas. Why? Because the ratio of the perimeters is a to b, because that's the scale factor. And so we're going to take the square roots, positive square roots, of everything here. And so that gives us square root of a squared is a, square root of b squared is b, equals, can you take the square root of 2xy? Yes or no? No. There's no perfect squares in there, so you leave it as the square root of 2xy. Can you take the square root of xy? No. So you leave that as the square root of xy. But then what do you have to do? Is this rationalized? Did they rationalize above here? Right? So we're going to have to rationalize. So what do you multiply top and bottom by? The square root of xy. So square root of xy, square root of xy. And so that's going to give us, what happens when you've got 2 x's underneath the radical, because I can put all of this under one radical. So what happens with the 2 x's? They come out in front. What happens with the 2 y's? One of them comes out in front. Where's the 2 going to be? Underneath. So you end up with xy, square root of 2, over, what's the denominator going to be? xy. What happens to the xy's? They cancel. So your ratio, and because it's a ratio, you are going to write it over 1. It's a ratio. You have to have it as a fraction. And so the ratio of the perimeters is square root of 2 to 1, because the scale factor is square root of 2 to 1. So that was a lot of work to get there. So make sure you have your notes handy when you're doing your homework tonight.